Good to go.
Welcome, everyone. I'm Patrick Johnson. I'm the CMO at APT and the co-founder of Nodal IQ. With me is Mark Hornbeek. He's the CEO of Engineering DevOps Consulting. Both of us here today to introduce you to a new concept called the Agentic Shift. In today's session, it's not a chapter by chapter walkthrough of our white paper. For those who have signed up that are here today, you have received a link to our white paper. We will also send it to you after the webinar. This is about something important. It's a little reframing of a problem most of us have been living for years that's been in this industry, and without having the language to name it. Essential question I have to leave with you all is your validation system scaling as fast as your production systems? If not, validation is already becoming your constraint and on innovation. And this gap is widening. We have about 35 to 40 minutes. The white paper will give you much more depth. We're just going to be covering the surface of the concepts that are in that paper and our experiences. And this session is going to hopefully create some sense of urgency now with the advent of AI. So a little bit of ourselves, quick context to who we do and who we are and what we do. I'm Patrick Johnson. I've been in this for 25 years, enterprise tech networks, and in the last several years now, AI go-to-market. I am the co-author, along with Mark, of this white paper, what we spent a lot of time on and sharing our experiences over the last couple of years as it relates to bringing AI into the testing space, specifically network test labs. Today, I help with the agentic test infrastructure for these labs, along with the help and support of Mark. Mark, I'll hand it over to you to introduce yourself.
Hi guys, everybody. Welcome to our webinar. So I'm Mark Hornbeek, and actually I'm referred to as DevOps the Gray because I've been doing DevOps for, I claim, something like 50 years, long before it was called DevOps. So mostly focused on engineering, research, development, a lot of focus on testing throughout my career. And of course, DevOps, I was awarded the IEEE Outstanding Engineer in 2016 for that work. I am an author of a number of books, mostly in the area of DevOps and continuous testing, contributed to some international standards on testing, and co-author of the white paper. So appreciate the opportunity to talk to you today. Thank you for inviting me into this, Patrick.
Well, we're glad to have you here, Mark. So a little bit about what we have planned for you today. So one is we're going to just cover the pattern, something that appears quite obvious and timeless. And Mark is going to cover that in great detail. And what's changing from what we've seen in history and to what is not changing. And what's law, it governs it all. We'll cover what we refer to as the wall. And the wall is this well-known deployment of improving productivity in the lab called scripted automation, and what's making it worse, what's breaking it, and what's not getting better. The shift, a new operating model. We're not introducing a new tool. It's about doing things differently. And the last is the move, what it means for your organization, and also the cost of waiting. So let's get into it. So what I want to start with is a single line here. This is in the agentic age, one engineering principle remains timeless, and that is automation is only as good as the data it acts on. Every era of testing is rediscovered this, and every area has tried to skip it. The agentic shift doesn't change this principle. It raises the stakes, in fact. Mark is going to take it from here because this principle didn't start with AI. It's been here for some time. And it's the gating factor of this transformation and the transformation that we've seen over the decades. Mark, off to you.
Thank you. Yeah, so what you're describing is a critical principle, all right? It's not purely philosophical. There's a very specific engineering form we call the governing law, which is V sub V is greater than V sub P, meaning validation velocity must exceed production velocity. If it doesn't, validation becomes a constraint on the system, not eventually, but predictably. We make this real at Bell Northern Research long ago. I worked on a global lab automation program. There were 13 many $1 million mega labs across the world. Very serious expectations. Everyone thought the hard problem was automation when we started a large lab automation project, but it really wasn't. The hard problem was structure. We didn't have a consistent way to represent the lab inventory. There were different sites, different namings, different assumptions across the different labs and teams. So the automation had really nothing stable to start with. We had speed in production, but we had no velocity in validation. And that's where the program slowed down. That's where the cost accumulated, and that's where lessons became clear. You can't automate what you have not first structured. That wasn't just a tooling issue. It was a validation velocity problem, and that problem hasn't gone away with modern systems. It's gotten worse. In the agentic era, your test artifacts are no longer just internal assets. They're inputs to reasoning systems. If they're inconsistent, incomplete, or unstructured, those systems don't fail loudly. They just slow down, or worse, they produce confident nonsense. Look at the bars. Production is accelerating. Validation isn't. The gap is not just inefficiency. It's the constraint in your system. Most organizations are operating in that gap right now, and because it happens gradually, it feels normal, and that's what makes it dangerous. Next slide, Patrick. So this slide basically is talking about building knowledge. To understand why this momentum carries, you have to step back. There isn't a story of disruption. It's a story of accumulation. Start with waterfall. It gave us some discipline around specifications, formal requirements, reviews, gates. Most people think that it's obsolete, but it really isn't. Those artifacts are now the deterministic anchors that systems reason against even today. Agile came next with iterations, test-driven development, continuous integration, test coverage. That didn't replace the waterfall discipline. It operationalized it. Tests became executable intent. Today, those tests are not just qualified signals. They're inputs. They're what reasoning systems consume as truth. DevOps extended that further. Pipelines, infrastructure as code, observability, site reliability, engineering. Now you have continuous delivery, but more importantly, you have control. Those pipelines and signals are the rails, the guardrails. They define what actions are allowed and what outcomes are acceptable. And now we arrive at agentic systems with reasoning, decision-making, closed-loop behavior. But notice something, none of this works without everything that came before it. The agent doesn't reinvent the ground truth, it inherits it. I've worked across all of these eras. Knowledge doesn't expire, it compounds. Each layer becomes more deterministic, more consumable, more actionable. So this is not a replacement curve. It's a stacking curve. If you skip the earlier layers, you don't move faster, you lose structure. And without structure, these systems don't accelerate, they drift. Over to you, Patrick.
Thank you, Mark. Before we talk about solutions, let's be precise about this. The nature of this problem, Mark, is highlighting the most common response of falling behind on validation is let's add more scripted automation. This has a fundamental limit. Mark, why don't you walk us through this concept?
Yeah, so this kind of looks like a busy chart and intentionally so. There are many surfaces in our systems today, in our modern distributed systems, that make it complicated. On any given day, this is what a test lab is being asked to validate. Different stakeholders and cases, different infrastructure topologies, different test types. Each one brings its own assumptions, its own failure modes, its own definition of correct. Individually, none of this is overwhelming. Together, it multiplies. Stakeholders times infrastructure times test types, not dozens, but thousands of validation requirements. And they don't run one at a time, they run in parallel. Now look at the highlighted path. That's the simplest case. One stakeholder, one system, one test. That's a single scenario. The lab isn't running one of those, it's running thousands at the same time on environments that are changing while the tests are running. That's the surface area of the complexity. And this is where most automation breaks down, not because the scripts are wrong, but because the system they're trying to validate isn't stable enough to reason about. That's the problem we're having to solve next with Agentic. Over to you. Oh, I think this is my slide. Okay, sorry. Yeah, so this slide is talking about when a automation turns on itself. The idea is that scripts weren't a mistake. They were the right solution for a different environment. The problem now isn't bad scripting, it's structural incompatibilities. Scripts assume the system they interact with is stable enough to reason about, but modern systems aren't like that. There are three forces all moving in the same direction. APIs are changing continuously. Every interface shift breaks an assumption. That's not an edge case, that's the norm. Infrastructure's reconfiguring dynamically. Every script you add carries embedded assumptions about the state, timing, and dependencies. And these assumptions don't stay aligned, they accumulate. And then there's dependency churn. Systems change faster than the validation layer they track. So the failure mode shifts, not more defects, more confusion, false negatives. Engineers spend their time debugging the validation system, not the product. Now put it all together. The more automation you add in this model, the more surface area you create to maintain. You don't get linear acceleration, you get compounding drag. At some point, the system stops speeding up, it starts resisting, and that's the wall. Over to you, Patrick.
What Mark has described is really a structural mismatch between a static tool, the script, and a dynamic world. The agentic shift is not about adding a smarter script or about a better orchestrator. It's about changing the operating model for validation entirely. Same tools, new operator. The next three slides build it, where AI belongs, what doesn't change, in a loop that makes the new model run. Mark, do you want to bring us through that?
Okay. Yeah, so this slide looks a little complicated, but if you think about it, there's just a couple of zones here, and they're not interchangeable. They meet at a boundary. The answers, the question, the answer to the question everyone is asking is, even if they're not saying it directly, what changes and what doesn't? Start with what doesn't. The entire left side, requirements, test strategy, artifact definition, standards. These are not optional. They never were. They're deterministic. They define what correct means. AI does not improve them. It depends on them. Now look at the right side. This is where AI belongs. Test generation, plan selection, execution, analysis. This is where humans have always been the constraint, not because of capability, because of bandwidth, because of scale, because of combinatorics. 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 Sorry. So walk it forward. Test cases used to be handwritten, limited, incomplete. Now they can be generated from intent, but still governed. Plan selection used to be manual, prioritization. Now it's reasoned, mapped to artifacts with human approvals. Execution used to be static scripts. Now it's orchestrated environments, adaptive and stateful. Results used to be reports read after the fact. Now they're analyzed in context and fed back to the system. Truth flows from the left. Outcomes flow back. The loop matters. AI accelerates the right side. It raises the ceiling, but it does not replace the left. If the left side is weak, AI doesn't fix it. It amplifies it. Okay. This is an even more complicated looking slide. So there's three parts. There's three columns. Don't read them necessarily separately. Read them as kind of as a sentence. The standard delivered by this capability requires this in your lab. So start with the first column, the standards. Nothing here is new. Good testing has always required clear intent, structured artifacts, traceability, coverage, accountability. This doesn't change. AI doesn't redefine quality. It exposes whether you actually had it. Now the second column, what AI changes, not the goal, the operating model. Memory moves from tribal to externalized. Intent moves from procedural to declarative. Execution moves from static to adaptive. This is not optional. This is what the systems require to function. Now the third column, what your lab actually has to do. This is where it becomes real. Knowledge retention becomes operational memory, not documents, queryable history. Past runs, decisions, root causes, something the system can use, not just humans. Automation of intent becomes intent-based execution. You stop writing scripts, you describe outcomes, and let the system derive the procedures. Your existing test as code work, that's on your ramp. That's your on-ramp. Throughout becomes machine scale validation. No more engineers, more parallelism, multi-agent orchestration. Capacity-aware scheduling. The ceiling shifts from headcount to architecture. So now landed, none of this is a product. There's no tool you can install to get there. These are practices. They have to be designed, they have to be built, and they have to be maintained. Next slide. So how do agentic AIs operate in this workflow? This is where the shift occurs, not a new tool, a new operator. The system still has the same components. What changes is how they're used, 5 steps, and how they operate as a loop. Start with sense. The agent anchors itself in reality, requirements, constraints, topology, prior results. This is the governance layer. If that layer is weak, the agent doesn't become intelligent, it becomes blind. Then reason. The agent forms a plan. What needs to happen? What tools are available? What sequence will produce this outcome? Not a script, an outcome-directed plan. Then act. The agent executes, generates test cases, selects from suites, maps to resources, runs the system, produces artifacts. Nothing magical here, just faster and more adaptive. Then verify. It compares what happened to what was intended. If they don't match, it doesn't stop. It adjusts, re-reasons, runs again. The loop continues until convergence, or if it can't. Now the last step, learn. This is the difference. On success, it captures what worked, not as documentation, as operational memory. On failure, it records the gap. What was missing? What assumptions broke? What capability wasn't there? And here's the key moment. When the system cannot succeed, it doesn't fail silently. It doesn't produce noise. It identifies the limit. which tooling is missing, which context is incomplete, which constraint was violated. That output matters. It tells you what to fix. That is the shift. Scripts crash, agents diagnose. Next slide. So here we're talking about the 7 foundations to hold up the loop. So what actually has to be true for that loop to operate is not in theory, but in practice, 7 foundations. Each one supports a part of the loop. None of them are optional. Again, start with sense, structured truth, and continuous context. You need a machine readable model of the system. You need current state plus history. Without both, the system isn't grounded in reality, it's guessing. And now reason and act, intent over implementation, decoupled intelligence. The system plans against outcomes, not procedures. And the reasoning layer must stay separate from execution. If it doesn't, scope expands, coupling increases, and the system becomes harder to control. Then verify closed loop autonomy. The system has to compare outcomes to intent and feed the result back into the next step. Without that, you don't have a loop, you have execution. And then learn progressive autonomy. Autonomy isn't a given, it's earned. The system expands what it's allowed to do based on what it has proven it can do. And then there's the last one, speed, not as a goal, as a consequence. When the other 6 are in place, the loop moves faster. When they're not, speed becomes instability. Next slide.
Thank you, Mark. Mark has shown you the operating model and the foundations underneath it. I want to spend the remaining time on what it means for how you structure your thinking and your organization now, and what questions and the question is not whether to adapt, it's how fast. So many of these slides that you see look fairly complex, but our environments are complex. And what this picture is trying to illustrate is what it means to when we say agentic shift. At the bottom of this is the world that APNT and Nodal IQ live in. We live in a networking test world, and this represents the infrastructure. And this infrastructure does not change, right? The agentic shift happens above the metal in a networking lab, right? The devices, the racks, the cables, the power, none of that changes. The engineers and the operators shift from doing to gating, right? They define the intent, they gate the autonomy, they review the outcomes, the agents handle the scale. So on the left side here, very similar to what Mark was saying, right? Before and traditional, much of this doesn't change, it exists, right? However, on top of this, we have the agentic shift. Workflows, orchestration shifts from scripts to intent. Hand-built, brittle pipelines become agent orchestrated. They become intent-driven. They become paralyzed. That creates the speed. Test generation execution shift from authored to reasoned. Hand-authored cases become AI generated, and they're adapted to the harness underneath. The reservation and topology shift from procedural to declaration. Shared calendars, manual deploys become declarative templates with deploy, verify, clone. Drift services as a typed signal, not as a forgotten ticket. Inventory and standards shift from tribal to structured. Spreadsheets become machine readable. Everything becomes machine readable as inventory with a full change log and standard encoded as templates. At the bottom layer, the physical infrastructure does not change. The metal stays the metal. And this part, most people get wrong about the agentic shift. They think it's an infrastructure replacement. In fact, it's not. The work is in software. The data is in process, not CapEx on new hardware. This is where the framework becomes concrete. It's simple. The real-world transformation by practices not the products. 3 steps in this order. Step 1, the structured truth. Outcome, every device, link, topology, role, reservation lives in a single machine readable source of record with full change history. The cost, months of unglamorous data work. In fact, this is the part of this job that most people don't like doing. It's the planning, it's the aggregating of the data, it's finding what matters, it's filling in the gaps, identifying the work necessary to fill those gaps and fill them. You unlock it. Every higher capability now has something to reason against. Step 2, make intent the contract. Outcome, topologies and tests defined as outcomes, not procedures. The system reconciles real state and intended state. Cost, the structural shifts. Stop describing implementation steps, describe outcomes. Unlock, the lab becomes reasonable by something other than a human. Step 3, close the loop, earn autonomy. The system senses, plans, acts, verifies, and learns, all bounded with authority, with humans where it matters. You now have discipline, resisting autonomy, faster than verified confidence in the hardest structural cultural shift of the 3. Now you unlock the loop that runs. VV approaches VP, the constraint starts to lift. 3 steps in this order. Each one earns the next. There is no shortcut to any of these steps, and no value is stopping at step 1. Mark, why don't you take everyone through the risks of standing still?
Yes, I think by now you've seen there are significant risks if we don't embrace agentic. The risk isn't so much failure events, it's more about accumulation. Production keeps accelerating, validation doesn't. The gap doesn't stay neutral. It builds a backlog of unvalidated change. At first, nothing breaks, then releases start slowing down, not because teams got worse, because the system can't keep up. Then quality, the usual response is to cut coverage, ship faster, catch up later, technical debt. That doesn't recover speed, it creates more debt and more defect debt. Now you're trading visible delay for hidden risks. Then confidence. When validation becomes unreliable, engineers stop trusting it. They compensate, more manual checks, more hesitation, or they ship without conviction. None of these things scale. And then the part most people underestimate, the competitive gap. Some organizations are already building this differently. They're increasing validation capacity, not just production speed. The difference compounds quietly until it isn't quiet anymore. So the decision isn't whether change is coming. It already has. The decision is timing. Do you build the capacity now when you can do it deliberately, or later when the constraint is already visible to your customers? Next slide. Okay, so before we move to Q&A, there's one question we encourage you to take with you. Where's your organization now? Is it in this progression? And more importantly, what is the next step you would actually take? Not the full transformation, the next step. These things that you can do. Read, understand the model, not at a high level, in detail. Assess, be honest. Where are you now? Starting early isn't a problem. Staying there is. And then talk. These systems are specific to your environment. Those details matter. With that, I'd like to say thank you for the opportunity to talk to you today. And Patrick, do you want us to wrap it up?
Yeah, thank you, Mark, and thank you, everybody. I hope this shared some perspective and the urgency that is needed here as we approach the agentic age, and how important the agentic shift is for testing in your labs. We'll open up for questions. If there's any questions, and
I'm not seeing any questions in the Q&A. No, but we had anticipated some questions, so we can walk through some of those. Um, and if anybody has any additional questions, we'll keep an eye open on the question window. So the first question we had is, where should we actually start with agentic AI in a test lab? And the simple answer is start in the right side of the problem. Don't try to redesign governance first. Take one constraint use case, maybe test generation, plan selection, or results analysis, and then apply agents there. At the same time, anchor it to something deterministic, like existing test artifacts, known topologies, prior results. If you skip that action, the agent doesn't become powerful, it becomes unpredictable. So the starting point isn't add AI, it's where do we already have structured truth that an agent can operate. I see a question in the chat now. What products can you use to help get this done? Patrick, do you want to take that one?
yeah, so there's several. One is from the grounding in the network test lab. There's tools we have. One is Nodal IQ, nodaliq.com, that does orchestration. So the other orchestrators like Velocity from Keysight is a really good tool for the lab that helps you ground the infrastructure and build that agentic layer on top. Another one is Toka Labs from Allied Telesis is also a good tool for that. And other tools that we use also with NoLikeQ is Netbox, as long as you have a good source of technology. From the agentic development, there's a number of applications that we use. We build from Cursor and Claude a number of applications around APIs on existing tooling that run in the lab that can work in this environment. We also have another couple applications called Mission Control, which is a agentic support system that allows you to ground all your documentation that's in your lab to your intent for a number of test tools from Keysight and Viavi that we use in these labs. And also we have another set of tools called Mission Command, which are some CLI and MCP tools that allow you to ground your agentic intelligence to these orchestrators, and several others that we can use.
Yeah, so some of those tools are ones that I know you and your team worked on. So definitely hope there. Is your email available? People can contact you, Patrick, in the slides. I
Yeah,
didn't
so I'm
notice.
available at patrick.johnson@apnt.ai. I am, part of the APNT in Netherlands, NL. So there is an APNT.L I'm also part of. And you can also reach me at patrick.johnson@nodaliq. Also, a company that I also run as part of an AI research that actually instigated this work. We've been working for several years on modernizing these labs to be more agentic, and this is where much of our innovation is coming from.
I see a couple of other questions in the Q&A. Maybe I can take the next one and then you take the one after. So William said, what's the commercial value of Agentic Shift? Does it reduce the cost of running current labs, or does it only increase quality? The simple answer is both. The automation in general has a pretty high return on investment from a cost savings point of view. There's always some investment, though. It does take some effort to get all your sources of truth in a form that agentic can use it. The other, automation and getting teams on board with it all and training and all that. So there's an upfront cost, but having invested that, it absolutely accelerates testing. And if you're doing it properly, it accelerates quality as well.
Yeah, and I think, Mark, I think one of the other things it does really well is it helps you scale your expertise. Your labs tend to be, no matter what you're testing, those environments are always very complex. Every scenario to every scenario you're trying to validate. What AI does very well is pattern recognition, learning from those patterns. And that no longer is left to one individual that you need in the environment to help support those complex scenarios or corner cases. So AI can learn from that and help multiply the expertise in your test environment and self-serve your end users much more quickly, smarter, and continue to learn. And that's you get that reliability.
Yeah, I see another question in the chat, which maybe we can both answer. If I need consultancy, can APNT or Mark help advising? So, Patrick, maybe you want to talk briefly about what services you have available to help people, and I'll mention mine.
Yeah, yeah. So we have a number of services here. So we have the ability to help, first off, bring you through this agentic curve, ensuring that those best practices are in place before you jump. To Mark's earlier points, in his years of experience, both him and I have been through this, is we've seen bad automation implemented. I always say successful automation is automation that's adopted and used, instead of some corner case run by some individual. So it's really important that you deploy by planning first and making sure that those prior systems are functional and operational with the right tools. So grounding your environment is absolutely the most important thing you need to do before you start trying to scale up agentic technology in that lab environment. Uh, of course, many of you could use, ChatGPT or, Claude or any of these other tools as individual independent users. But when you try to scale up and learn in a team of people, that's really hard. So that's something we can help you with. We can help you ground to the tool sets that you're using for testing, by building MCPs, by building workflows and orchestrators um, that actually deliver deterministic outcomes based on that infrastructure. And we can also help manage and operate it for you. Mark is a thought leader, so I've worked with him for years. He's got all the known best practices, use them all the time as a consultant for us, and he can also help in a lot of the planning and thinking that's necessary to do the right things. So, Mark, I don't know if you want to add your abilities here.
Yeah, I would just say that I'm available as an independent consultant under my website, engineeringdevops.com. But in this context, with obviously agentic AI network labs, definitely Patrick and I can help together, collaborate on any specific projects, whether it's a project solely for advice or even an implementation. So our two companies can collaborate together under different arrangements. We're pretty flexible in that regard. And certainly, this we've had a lot of experience working together, not just for this webinar, but over the years. Patrick's kind of the Steve Jobs of network labs, and I'm kind of the Wozniak.
I
We
like that
work
analogy.
together. Yeah, cool. Yeah, I think do we have a few more minutes? We had one more seed question we put
Well,
in here.
Mark,
That maybe, yeah,
Mark, I
go
think
ahead.
there's one question I know that you and I talk about a lot. We get these questions from our customers.
Hmm.
And this is the obvious hard question. And Mark, how do you trust these agentic systems in a validation environment? Like,
Yeah.
how would you describe that from your experience and the work that we've done?
Well, yeah, I actually wrote a book on this topic together with a couple of colleagues on engineering respect and trust, as well as something called human debt. So you can't just start with trust; you have to build it. That's a mistake. Some teams think they can't just teach trust. You have to treat AI like a capability upgrade, where it's viewed as a new operator. So you introduce it with constraints, human in the loop approvals, bounded scope, clear success criteria, and have data that you can get confidence with. Then you expand the authority based on the observed performance, not just it's got to be earned confidence and with evidence. If you skip that progression, you don't really get autonomy. You just get more risk. Okay. I thought I saw one more question in the Q&A, but it
And
disappeared.
Mark, what what breaks first? I mean, if your team tries to do this, you know,
Yeah. So, the data is the data. It in and of itself doesn't break, although there's an effort to get all your data in order to provide that source of truth. So it's usually not the models or the tools. Um, so the inconsistent naming, incomplete topologies, test artifacts that don't reflect reality. Agents depend on that structure. So if your environment is loosely defined, the agent doesn't fail loudly. It produces plausible output, and that's being used wrongly in many subtle ways. So that's harder to detect than a broken script. The first failure mode isn't technical; it's structural, like we said in the webinar. And fixing that is where the real work is up front.
yeah, I think the first thing that comes to mind is what breaks first is when you when you start to scale up your data from many different types of data sources, and you're asking AI to like make it all work together. If you don't provide the necessary structure of how that data works together, you'll get gaps. And what AI's great capability is also its weakness, and that is it likes to fill in that with its own intelligence, and that's called hallucination. So that's a feature of AI. And the only way that you can prevent that is you need to run those procedures and test them and then fill those gaps. And that's all part of enriching your grounding. You have to make sure that the grounding is filling in those gaps and ensuring that these systems are properly integrated with smart grounding procedures so that, and that's part of adding the human in the loop and validating and testing that. But once it's in and you close those gaps, the grounding just gets better and better and better, and it learns and it becomes more autonomous. But the hard work that the what breaks is the unwillingness to do the hard work, and that's when the system doesn't scale, it breaks, and it's just again back to one person that knows how to do AI, just like one person that knows how to do automation.
Okay, I think that's all the questions, right? And it's pretty much we're running out of time, so
Yep.
down to the wire.
Yeah. So thank you everybody for joining. We'll follow up. We'll share both the webinar, and please share with your friends and colleagues. Be great if you need to reach out. Our information we hear will also provide it to you, and also send you a link to the white paper that brings much more detail to these concepts. Again, thank you very much, and I'll wish you a good day. Thank you, and thank you, Mark.
Thank you.